Hey guys, I wanted to introduce the last part of our formulas and bonding chapter, which is about naming covalent compounds. What we've done up to this point is we've talked a lot about ionic compounds. Remember that ionic compounds had to do with charges. We went through and we figured out that there's a positive and a negative for all ionic compounds. You name the positive ion, you name the negative ion. And to come up with formulas, you have to look at the ratios of charges, right? So we went through and we talked about how you can kind of go through and figure out, how the charges match up to come up with a formula for an ionic compound. Covalent compounds are very easy to write formulas and names for. Remember that a covalent compound, let me scroll down to the right page. Remember that a covalent compound is only nonmetals. Okay, so the only way that you're going to ever use these rules is if it's a compound with only nonmetals. Okay, if there's any metal in it, it's got to be an ionic compound. Okay, so the rules that I'm going to teach you today only have to do with compounds that are only nonmetals. Some of you already figured this out from the worksheets that you've turned in about telling the difference between ionic and covalent compounds. You've already gone through and you've named a few, or you've written formulas for a few. Covalent compounds are not based on charges. They're based on atoms sharing electrons in different ways. So they're carbon tetrachloride is the example that I'm giving you here. If this was an ionic compound, you would just call it carbon chloride, because there'd only be one combination of charges that would lead you to this formula. But we put this tetra in here because there's more than one possible combination. There could be a carbon trichloride or a carbon dichloride, where carbon would be sharing electrons in different ways with chlorines. So we have to come up with prefixes to distinguish the different ways that it's sharing. Prefixes are, the first couple are kind of hard to remember, but most of them are pretty easy. Prefixes just tells you what the subscript is going to be. So this is totally different from the whole idea of charges with ionic compounds. Okay, so I'm trying to move this up, but the prefix just tells you how many of that particular atom there are. Okay, so mono would be one, which I should put an asterisk on that. Mono we only use in a couple circumstances. So mono only works if it's on the second element, but for all the rest of them, we always use them: di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And so except for the di, tri, and tetra, you can remember tetra like Tetris, you get like 4 lines in a row. These are all Greek prefixes here. So like pentagon, hexagon, heptagon, you can remember them that way. There's just a Greek prefix for these. Or actually, you know what? These might be Latin prefixes now that I think about it. But anyways, if you see a compound, the way that you go through to use the prefixes to name it is you look at the elements that are there and you write them in the same order. So the example for the CCl4, I would still put them, I would have carbon and chlorine. Second one always has to end in "ide," which is the same rule as for ionic compounds. But for ionic compounds, you would just stop here. You would just call it like sodium chloride and you would end there. But for covalent compounds, there's this added rule with putting a prefix in there. Okay, you put a prefix in which names how many of each element is with that or what the subscript is on that element, basically. And the last rule for using prefixes is you can never start the name with mono, which is sort of a goofy add-on. So if the first element would begin with mono, so in other words, if the subscript on that one was 1, you wouldn't include that. So for all the other ones, you keep it, but just for the mono, you can't actually start it with mono. So let me show you some examples here. So kind of going through that, carbon chlorine would be these two elements. I would end it in "ide." okay, because I always have to end the second element in "ide," which we're used to doing for nonmetals anyways. But then I have to include this 4 somehow. So there's 4 chlorines, so I'm going to put the prefix tetra on there. Tetrachloride, carbon tetrachloride. And since there's 1 carbon, normally I would put a mono here to make 1 carbon, because there's just an invisible 1 here. 1 carbon and 4 chlorines. But we can't start the whole name with mono, because I guess if you were looking up compounds in a book, they would all start, a huge number of them would start with mono, mono, mono. So we'd actually avoid using mono if we could avoid it. I'll do some other examples with you all. So here I have nitrogen and chlorine. So I'm going to call it, normally I would, if it was an ionic compound, I would call it nitrogen chloride. But I'm going to put some prefixes in here. Since there's 3 chlorines, the prefix for 3 is tri. And the prefix for 1, there's 1 nitrogen, is mono, but remember I can't start with mono. Okay. The next one is phosphorus and nitrogen. So normally I would call it phosphorus nitride. But I can't, I need prefixes in here to indicate how many. I have 1 nitrogen and 1 phosphorus here. So I would put a mono for 1 nitrogen. I have 1 phosphorus as well, but remember I still can't start with mono. So I'm just going to leave it this way. Next one would be sulfur and oxygen, but there's lots of ways to combine sulfur and oxygen. So I'm going to call it sulfur oxide. Okay, and I need some prefixes in here. There are 8 oxygens, so I'm going to call this, the prefix for 8 is octa, so I'm going to call this octa oxide, or sometimes we just drop the second vowel for octoxide is also acceptable. Now, since there's more than 1 sulfur, I don't have to use mono, I need to use di to indicate 2. So I'm going to call this disulfur octoxide. And now I am allowed to start with a prefix that's something other than 1. We've got another one here, NaNO3. Oh, I got too many elements here. So I got sodium, nitrogen, and it's a trap. This is an ionic compound. Sodium is a metal. We can't have a metal in a covalent compound. So I would have to go back to the naming rules for ionic compounds here. The problem is, so you have to have all nonmetals to be a covalent compound. So this one I would just call, this is a polyatomic ion, I would call this sodium nitrate. Okay, so sodium's a metal, so this follows a completely different set of rules for naming. Okay, so be on the lookout for metals, because you know that those have to be just the plain naming rules for ionic compounds. Okay, only when you're all nonmetals do you use the prefixes like this. Okay.